Before you embark on this learning journey with me, let us understand the prerequisites for this course and also set clear expectations. This course is for admins who are new to automating tasks with Azure and an existing familiarity with the Azure platform and Azure management is expected. I would expect 3 things from you as my student. The first one is that you should already have hands-on knowledge on working in Azure and have basic understanding on PowerShell scripting. So just to let you know that PowerShell scripting will take you a long way in your career as an administrator. So learn PowerShell if you do not already know it. Then you should also have basic knowledge on Azure Log Analytics and basics of event grids and its capabilities. And last but not the least, start performing the labs simultaneously while I perform the demo for a better understanding on this subject. Azure Automation is obviously a service in Azure that allows automation of many Azure management tasks and activities. It is built using PowerShell, providing a robust platform having a vast reach and integration opportunities. And it also helps in the orchestration of actions across both external as well as internal systems right from inside Azure. When I say external, it means workloads that are outside of Azure. It can be in any other cloud or even on premises. It gives you complete control during the deployment, operations, and decommissioning of workloads and resources. Since a lot can be done using Azure Automation, it is considered as an expansive automation service while still remaining cost effective. How? Because the relative cost of deployment is low and is based on the pay-as-you-go model. It also brings down the overhead of the IT and service desk personal tasks, thereby saving a lot of their time and effort. We will see this in action in our demo and how it can make you a real hero in your organization when you implement it. In this course, we will discuss on 3 major topics. The first one is about the PowerShell runbooks. PowerShell runbooks are based on Windows PowerShell, providing a robust platform for automating processes. You can create and edit the code of runbook directly in the editor within the automation account. You will see this in action during the demo. Microsoft also has provided us with a set of pre-created runbooks for the common tasks like switching on the VMs, shutting down the VMs, and many more. Then we have the update management. This one gives you the ability to have insights into update compliance of the workloads, not just in Azure, but also non-Azure and on-premises environment so that actions can be triggered accordingly if needed. Last but not the least, we will be covering desired state configuration. As we had discussed previously, in case you wish to quickly and easily enable scalability for the workloads from a central secure location or wish to assign these workloads declarative configuration, that is, the default configuration that is expected on the virtual machines as per the organizational policies in order to enable and meet the compliance with the desired state, Azure Automation State Configuration is the answer. Now that we clearly understand the basics of Azure Automation and how it can be helpful, let us now shift gears to accelerate and learn the core capabilities and features of Azure Automation. The set of capabilities and features of Azure Automation provides consistent management of resources across Azure, non-Azure, and on-premises. It also gives you complete control during the deployment, operations, and decommissioning of workloads and other resources. And it also provides insight into update compliance of the workloads for actions to be triggered. So these points we had already discussed previously. But how does it do it? So the first one is the process automation. Process automation can be achieved using runbooks and brings the benefit of automating repeated, time consuming and error prone end-to-end processes and management tasks. It actually lets the IT and service desk teams to focus on the actual work, thereby adding more business value. By doing so, it helps in two ways. First is by boosting the efficiency of the teams, and second is by helping in reduction of the overall OPEX, that is the operational expenses, operational costs. It allows creation of runbooks in a variety of ways, such as graphical runbooks, PowerShell runbooks, Python runbooks, and so on and so forth. We will see more about this in action when we configure the PowerShell runbooks with real-world example. It also has webhooks that enables event-driven reactive programming, ensuring seamless operations. The second one is the configuration management. Configuration management can be classified as having two features. The first one is the desired state configuration. The Azure Automation State Configuration AASC is management platform on PowerShell and is also known as desired state configuration. It enables you to manage the IT and development infrastructure with configuration as a code. And the second one is change tracking and inventory that allows management and tracking of any configuration or infrastructure changes. It tracks the changes not just on the virtual machines, but also across other services, softwares, and registries as well. And that is how it helps in monitoring and diagnosing changes that are unwanted and send notifications. The third one is the update management. We discussed about the update management and how it helps in automating the processes of updating and patching of the virtual machines to meet the update compliance. It is one of the most sought after features of Azure Automation. It works along with the log analytics to detect the vulnerabilities and any missing important security and other updates, and then mitigating the issues by automatically patching them. This way, it helps in keeping the VMs clean and healthy and also meet the organizational security policies. We then have the shared capabilities. Azure Automation provides a number of shared capabilities. Some of the key capabilities include the shared resources, role-based access control, and source control integration. Now, if we talk about the shared resources, they provide capabilities that makes the automation and configuration management tasks easier, and that too at scale. This includes schedules, modules and modules gallery, credentials, variables, certificates, connections, and Python 2 packages. And second in the shared capabilities is the RBAC, role-based access control, that I was just mentioning. Azure Automation provides role-based access control to automation resources for a fine-grained regulated access. And the next one in the shared capabilities is the source control integration. The source control integration feature of Azure Automation provides configuration as a code where you can use source control to check in runbooks and configurations. Lastly, we have heterogeneous. Azure Automation is designed to provide a consistent way to support in a hybrid scenario that includes Azure, non-Azure, and on-premises workloads and operating systems, which is both Windows and Linux. So those were the features and capabilities of Azure Automation. There is always a demand for process improvement in order to reduce the operational expenses and bringing down the cost. And we had been discussing on the plethora of possibilities with Azure Automation. You might be wondering as to why trust Azure Automation, isn't it? And that question is not wrong. You must make yourself aware about this before you even make an informed decision and suggest process improvement using Azure Automation Service in your organization. So there are two major reasons for trusting Azure Automation apart from the capabilities and features we just discussed. The first one is that Azure has more compliance certifications than any other cloud provider that are region or country specific and are enforced as per their policies. And the second one is that Microsoft is investing a lot of money for cybersecurity research and has employed a lot of security experts dedicatedly working on securing data and privacy. On to our first demonstration, and here I am on my Azure portal. And in our first demonstration, we are going to create an Azure Automation account. But before we do that, we need to create a resource group. So here I have the resource group icon on my dashboard. So I'll click on it. And you will notice that I already have one resource group by the name of LinkedIn Learning Automation in the East US2 region. So we will be using that. And we are good with this. The next step is to create the Azure Automation account. And for that, I'll go straight away to the search bar and search for automation. The first option that you will see here is of automation accounts. So I'll click on it, which will take me to the automation accounts page. Here, I'll click on the create button, and this will take me to create an automation accounts page. Here I have different tabs, which is basics, advanced, networking, tags, and review and create. We'll see each one of them, but under basics, you will notice that the subscription is pre-filled for me. Why? Because I just have one subscription. For the resource group, I'll click on the drop down and select LinkedIn Learning Automation. For the automation accounts name, I'll give it a name of LinkedIn Automation. And for the region, it is East US2. There is nothing else to configure, but still I'll take you through the rest of the steps. So I'll click on next. This will take us to the advanced tab of managed identities. By default, the system assigned managed identities is checked, and it will create a system assigned managed identity. We can also create a user assigned managed identity, but this is not needed for this demo. So I'll click on next. This will take me to the networking tab, and under network connectivity, you will see connectivity configuration, which has two options. One is the public access, and the other recommended way is for the private access. But for the purpose of this demo, we are good with everything else. There's nothing else to configure. So I'll click on review and create. And once the validation has passed, I'll click on the create button again. This will take a couple of minutes before the automation account is provisioned. So we will wait for this to be completed and return back once this is done. Now, as you can see, the Microsoft Azure Automation account has been provisioned. So we can click on the Go to Resource button, and here I am on the LinkedIn Automation Azure Automation accounts page. On the right hand side, it shows the resource group name as LinkedIn Learning Automation, the location as East US 2, the subscription name, as well as the status, which shows as active. Now, these are all the settings that we provided while configuring the automation account. And now I wanted to show you three major things. And we had been discussing about those topics, but I wanted to emphasize more here while I have configured the automation account. So one is the state configuration, which is the desired state configuration. The second one is the update management. And the third one is the PowerShell runbooks. So I will move to the left and then scroll down. Under configuration management, we have state configuration, which is the desired state configuration. I have already explained earlier that if you want to align machines to organizational policy or to enable continuous deployment, it can be a tedious and error-prone process. And more, when the infrastructure footprint grows, so does its difficulties in this area, isn't it? Now, Azure Automation Desired State Configuration provides a highly available configuration management solution to help you with the issues that we just discussed. Using Automation DSC, which is a desired state configuration, you can consistently deploy, reliably monitor, and automatically update the desired state across physical and virtual machines, be it Windows or Linux machines, in the cloud or on premises, thereby enabling continuous deployment and IT services delivery with consistent control. Other than that, we have update management under update management. Update management collects information about system updates from Windows and Linux machines with the log analytics agent installed and installation of required updates. Update management integrates with Azure Monitor Logs to store update assessments and update deployment results as log data from assigned Azure and non-Azure machines. And since update management integrates with Azure Monitor logs, we need to first create the log analytics workspace, and that is what you can see from here. It is asking for log analytics workspace name, and we need to first create that, and then it integrates with update management. We will see this in detail in demo later in the course. The third one is the runbooks under process automation. Runbooks are stored and managed in Azure Automation and then delivered to one or more designated hybrid worker computers. Not only does Azure Automation leverage the existing PowerShell modules, but it also offers different programming options to further extend the usability. So there can be graphical runbooks, there can be PowerShell runbooks, or even Python runbooks. So if I move to the right and then click on create a runbook, I can create my own runbooks. I can give it a name. From the drop down for runbook type, I can click on it, and here you see different options. There can be PowerShell runbook, Python runbook, PowerShell workflow, graphical PowerShell runbook, or graphical PowerShell workflow. So I can choose one of them. Say I choose PowerShell. Then from the runtime version, I can choose from the different options available. So there are two versions for PowerShell. So one is 7.1, which is in preview, and then we have 5.1, which is more stable. I can choose one of them and then click on create. So I'll not do that, and I'll just move back to LinkedIn Automation, click on OK, and I'll show you what import a runbook is. So I'll click on it. Here I can either upload the runbook from my local system, which is browse for a file, or I can browse from the gallery. So I'll click here to browse from gallery, and here you will see a plethora of runbooks already created by Microsoft so that you can use them as per your organizational requirements. Here you see that we have multiple runbooks available. So one is Azure V2 VMs, which we can start, and then we have start Azure VM, then we have stop Azure V2 VMs, and so on and so forth. I'll go back to LinkedIn Automation, click on OK, and then we have browse gallery. It will show me the same list of runbooks that are available for me to use. So I'll go back to LinkedIn Automation, and other than that, there are other things that I wanted to show you. So I'll go to shared resources. Under shared resources, we have schedules, modules, Python packages, credentials, connections, certificates, and variables. Let's try to understand a few of them. So if we click on schedules, we can define a schedule and have the runbooks run as per the stated or as per the defined schedules. Other than that, we have PowerShell modules that we were just discussing. We can import these modules in our PowerShell runbook and then code as per the requirement. Apart from that, we have Python packages. So we can add a Python package from here and then use it within our Python runbooks. We also have credentials which we can add here, and then we can give permissions to this particular automation account in different Azure services. We also have connections, certificates, and variables. So if I click on variables, it allows me to add a variable with different data types. And these variables are basically global variables which can be used within the PowerShell or Python runbooks. So I'll scroll down a little. Under related resources, we have linked workspace, which I already told you. We need to create a log analytics workspace for working with the update management and then link it. We can link it from here as well. We also have event grids. So we first need to create the event grid topic and then add it to the webhook so that it can run from the PowerShell runbook. It can be invoked from there. Other than that, we have the account settings like properties, networking, keys, pricing, and all other details. So the configuration of the automation account is complete, and we will work on the complete process in the later demos. Let us dig a little deeper into understanding the cross-services automation using PowerShell runbooks. Or we can say the process automation using PowerShell runbooks. I told you that process automation is all about automating manual tasks that are repetitive and time consuming. And when you automate such tasks, it's obvious that you are improving a process to bring down the costs and the efficacy of the tasks within the process increases. So why do we call it a cross-service automation? It is because, first, it lets you save time and lower the overhead costs. You can automate all of those frequent, time-consuming and error-prone manual tasks. This, in turn, helps in increasing the efficacy, lower operational costs, and also helps the team to focus on other productive work that adds more business value. Then, it is possible to integrate with other services. All the runbooks that we write in Azure Automation are simply PowerShell workflow. We can write runbooks graphically in Azure Automation or write graphical PowerShell workflow runbooks or the PowerShell code directly. In the first two cases, it will eventually generate the PowerShell code which cannot be modified or viewed. It helps to integrate with other Azure services so that end-to-end process automation can be deployed, configured, and managed, and eventually helps in the orchestration actions across environments. And last but not the least, it helps in delivering more reliable services faster. As the process automation relies on serverless runbooks to automatically grow as your operational tasks increase and deliver quick and consistent services, the focus shifts from maintaining and managing the complex system to growing business. At this stage, I'm pretty sure you have enough understanding on what Azure Automation is and its capabilities and features. And you might already be wondering on the plethora of implementation possibilities, isn't it? Let me guide you to one such scenario which is a part of a real-time solution implemented as a process improvement via automation. And we will work on the same implementation in our first demo on process automation. So before we begin with the lab, let me try to explain to you the end objective and how the system should behave post-implementation. In big organizations, users are allocated virtual machines. These virtual machines are hosted as Azure VMs with different set of capabilities depending on which department the user belongs to. The onboarding requests are raised by the end users or their managers in ServiceNow. This includes request for a new VM to be allocated. All the requests are consolidated by the service desk personnel in an Excel file which is uploaded to the Azure storage account. After the file has been uploaded to the storage blob container, an event is triggered and the associated event grid publishes a notification to the subscribers of the event. Here, Azure Automation listens to the event as a subscriber from the storage account and kicks off the first runbook, which initiates the process of reading the Excel sheet, one record at a time. This record is then sent to the second PowerShell runbook, which does the actual provisioning of the virtual machines. The second runbook also checks if the IP addresses are available to be assigned to the virtual machine. In case the subnet has already exhausted all the IP addresses, a new subnet is created and used for the VM creation. Also, a predefined network security group, NSG, is assigned to the VM to conform to the security requirements as needed. The reason for creating two runbooks is to keep the PowerShell runbooks code more modular and easier to understand. Also, we will make use of shared resources like credentials, modules, and variables for centralized management of automation service. Now that you know about the process flow, let me also outline the series of steps that we will be following to create and configure the cross-service process automation with the runbooks for the demo scenario we just discussed. The first one is that we will create an Excel file and this file contains the details of the virtual machines to be created. Then we will be creating a storage account, and this is the account where the Excel file will be uploaded. As the next step, we will create a virtual network where the virtual machines will be residing. Post that, we will also create a network security group, which will enforce the security policies on the subnet where the virtual machines will be created. After that is completed, we will configure the Azure Automation service, where we will first create a service principal. Then we will create credentials within automation service, create variables within the automation service, and import the required modules. Once this is done, we will create PowerShell runbooks, where after creating the PowerShell runbooks, we will assign permissions to the service principal at the subscription level, create and configure the event grid, and create webhook for listening to the events that happens in the storage account. Once that is done, then we will create the subscription to the events over the webhook. And that will conclude the complete process flow demo. On to our next demonstration. And here we are on my Azure portal. And in this demonstration, we are going to create two things. First, we will be creating a virtual network, and then we will be creating a network security group. And it is also known as the NSG. So for creating the virtual network, I'll click on the virtual network link here on my dashboard, which will take me to the virtual networks page. Here, I'll click on the create button, and I'm here on the create virtual network page. For the subscription, it is pre-filled for me. As I already told you, I just have one subscription, and that is selected by default. For the resource group, I'll click on the drop down and select LinkedIn Learning Automation. For the name under instance detail, I'll give it a name of LinkedIn VNet. And then for the region, it is East US 2. There's nothing else to configure. So I can click on review and create, but let me walk you through the rest of the steps. I'll click on next IP addresses, and here you will notice that by default, an IPv4 address space is created for us along with the default subnet. So we are good with this. There is nothing else to change. So I'll click on next security. Here also, there is nothing else to change or configure. So I'll click on review and create. And after the validation has passed, I will click on the create button. It is a quick process and will be done quickly. So here the validation has passed. So I'll click on the create button. The deployment of virtual network will take a couple of minutes. So we will pause the video here and return back after the deployment is complete. So the deployment of the virtual network is done. I can click on the go to resource button. And here I am on the LinkedIn VNet virtual network page. On the right hand side, as usual, you will see the resource group name, the location as East US 2, the subscription that was selected by default, along with the address space. And it also shows some other details. So let me scroll down a little, and under settings, I'll click on address space. Here again, you will see the same thing of 10.0.0.0/16. And if I click on the subnet, it will show the default subnet that was created with the available IPs of 251. So we are good with this. The second step was to configure the network security group. So I'll go to the search bar and type in network security group. And from the results that appear, I'll click on network security group. Once I'm there on the page, I'll click on the create button. And this will take me to the page where I can create the network security group. So again, the subscription is pre-filled. That is fine. For the resource group, I'll choose LinkedIn Learning Automation. And for the name under instance detail, I'll give it a name of LinkedIn NSG. There is nothing else to change or configure. So simply just click on review and create. And after the validation has passed, just click on the create button. Again, this is a quick process, and the network security group will be deployed quickly. So we will wait for the process to be completed and return back after the deployment is complete. So the deployment of the network security group is complete. I'll click on the go to resource button, and here I am on the LinkedIn NSG Network Security Group page. And here, if you see on the right hand side, if I scroll down, it will show a couple of inbound security rules as well as the outbound security rules. The same, I can see it from here under settings if I click on inbound security rule, and outbound security rules, it will show the same rules that were shown on the home page. For the inbound security rule, I'm going to add one more rule for port 3389. So what I'm going to do is open port 3389 so that we could RDP into it. So I'll click on add. And for the source, it remains as any. For the source port range, also it remains as asterisk. For destination is any. For the service, it is custom. We are good with this. And for the destination port ranges, I'll change it to 3389. And scroll down a little, and under name, I'll change it to port 3389. And once that is done, I'll click on the add button. This is a quick process, and port 3389 will be open for us with a little warning that 3389 can cause security issues, but we are good with this. So this concludes the demo where we created the virtual network as well as the network security group. On to our Azure portal again, and this time for this demonstration we are going to create a storage account. So for that, I'll go to the search bar and search for storage account, and from the search results that appear, I'll click on storage accounts. Here on the storage accounts page, I'll click on create, and this will take me to create a storage accounts page. For the subscription, it is already selected. For the resource group, it is selected by default as LinkedIn Learning Automation. So we are good with this. We'll scroll down a little, and for the storage account name, I'll give it a name of LinkedIn Automation. So this time, everything is in this small letter because we cannot give the storage account name in the caps, which is the capital letter. For the region, I'll change it from East US to East US 2 to let it remain the same as the resource group and other resources that we have created within the same resource group. For the performance, I'll let it remain as standard. For the redundancy, I'll change from geo-redundant storage to locally redundant storage. And there is nothing else to configure or change, but let me walk you through the rest of the steps. So I'll click on Next Advanced. Here, the only thing that I want to show you is the minimum TLS version, which is version 1.2. So this is a secure thing. If I scroll down, there is nothing else to change or configure. So I'll click on Next Networking. Again, for the connectivity method, by default, the public endpoint is selected for all the networks. So we are good with this. We'll click on Next Data Protection. Nothing to change. For the encryption, again, there is nothing to change. So I'll click on Review and Create. So we will wait for the validation to pass. So here you go. The validation has been passed. So we'll click on the Create button. Again, creation of the storage account will take a couple of minutes. So we will wait for the deployment to be completed. I'll pause the video and return back once this is done. Here you go. The resource has now been deployed. So I can click on Go to Resource button. And I am on the LinkedIn Automation, which is the storage accounts page. Again, on the right hand side, you will see the name of the resource group, the location as East US 2, the subscription as well as other details, which includes the performance details, which is a standard, along with the replication, which we selected as locally redundant storage. And for the account kind, it is storage V2, which is general purpose V2. So we are good with the deployment of the LinkedIn Automation account. The only thing we need to do now is to create container from under data storage. But we will do it when we are configuring the automation account again. So that concludes this part of the demonstration. In this demonstration, we will discuss about the Excel file that we will be using for our use case scenario. If you remember, when we were discussing about the use case in our first module, I told you that a ServiceNow request will be raised for every new joining in the organization for a virtual machine allocation. These requests will be consolidated as an Excel file that will eventually be uploaded in the storage account. And as the file gets uploaded, an event will be raised and the PowerShell runbooks will get triggered, which will process the Excel file to deploy the virtual machine so that the virtual machines are deployed and are allocated to the user for whom the request was raised. So here is the Excel file that will be used. The name of the Excel file is createvm.xlsx and it has different columns. The first one is name and we have two rows here. One is for VM1_Windows and the other one is VM2_Windows. So for our demo scenarios, we are going to deploy two different virtual machines. The second column is location, which is East US2 for both the virtual machines. For the resource group name, the name of the column is RG name and we have used the same resource group which is LinkedIn Learning Automation that we had been working until now. The fourth column is SKU, which is 2012 R2 data center. The size of the virtual machines will be standard DS1 V2. For the username and password, the column names are local admin user and password. Then we have the publisher name, which is Microsoft Windows Server for both the VMs. The offer name is Windows Server and the computer name are Computer 1 and Computer 2 respectively. We could have added more columns here like the virtual network name, the subnet name, as well as the network security group name. But we are going to configure it as shared variables. Why? So that it can be used with other things as well, like the update management or the desired state configuration apart from the PowerShell runbooks. So that is where we will be configuring them as shared variables. And also because I wanted to make this Excel file very simple for you to easily understand. So I have kept it to the bare minimum. Back to our Azure portal dashboard. And so far we have created the LinkedIn automation account, the virtual network by the name of LinkedIn VNet, the network security group by the name of LinkedIn NSG, as well as the LinkedIn automation storage account. Apart from that, we have also created the Excel file. And now is the time to create the user-defined managed identity. If you remember from our first demo, I told you that we will not be creating the managed identity and that is out of scope for that particular demo. And now is the correct time to create that managed identity. So since managed identity link is already there on my dashboard, I will click on it. If it is not there, you can just go to the search bar and search for managed identities. Now that we are on that page, we'll click on create. We are there on the create user assigned managed identity. I'll choose the resource group from the drop down, which is LinkedIn Learning Automation and the region as East US 2. So I'll scroll up. And here you have East US 2. So I'll select that and the name I'll give as Automation User ID. So this is done. I'll click on review and create as there is nothing else to do. So I'll click on review and create. And once the validation has passed, I'll click on create again. It will take a couple of seconds and the user defined managed identity will be provisioned. So now the user defined managed identity has been provisioned and I can click on go to resource and we can see the details of the identity. Now that the automation user ID has been created, which is the managed identity, I need to give this ID the contributor access to the subscription. So I'll click on the search bar and search for subscription. And here you have the first link. I'll click on subscriptions. And once we are there, we'll click on the subscription name. On the page, we have the access control IAM. I'll click on it. On the right hand side, I have role assignments. And once we are there, I'll click on add role assignment. From the list that appears, I'll choose contributor and then click on members. Once I'm on the members page, I have two options. One is assign access to user, group or service principal, and the other one is the managed identity. I'll click on managed identity and then click on select members. On the right hand side, I will choose the drop down for managed identity, and I have one user assigned managed identity. I'll click on it and it will show the automation user ID, the managed identity that we just created. So I will click on it and then click on select. Once that is done, I'll click on review and assign, and finally click on review and assign again, and it will assign the automation user ID, the contributor access, to the subscription. I can scroll down, and here under contributor you can see automation user ID. So we are good with it, and now we are going to configure the automation account. On to our next step of the demonstration, and here in this step we are going to configure the automation account, and for that we are going to perform two activities. One is to create global variables within the LinkedIn automation account, and the second one will be to import the PowerShell modules, and these modules will be used within our PowerShell runbooks. So here from the dashboard, I'll click on the automation account, which is LinkedIn Automation. And once we are there, I'll scroll down to the shared resources and click on variables. I'll click on add a variable, and the first variable that we are going to create will be of tenant ID. So I'll give the name as tenant ID. The type is a string, and for the value, what we can do is we can right click on the Chrome and click on duplicate, and once we are there, I can click on the main menu and then go to Azure Active Directory. From here I can copy the tenant ID, go back to my main page and then paste the value. Once that is done, we'll click on create, and a new variable by the name of tenant ID will be created for us. We are going to repeat the process to create the variable for storage account, virtual network, as well as the network security group. So I'll click on add a variable, give the name as a storage account. For the type, it is a string, and for the value, it is LinkedIn Automation. Once that is done, I'll click on create. Go back and repeat the process for virtual network. Give the name as VNet. The type is a string, and for the value, it is LinkedIn VNet. Click on create again. Go back and repeat the process for network security group. We'll give the name as NSG. The type remains a string, and for the value, it is LinkedIn NSG. This is now done, and we'll click on create. So we are good with creating the variables. We will now move on to the second part of this demonstration, which is importing the PowerShell modules. So for that, I'll click on modules under shared resources, and from here we need to import 7 different PowerShell modules. The first one is az.accounts, the second one is az.automations, followed by az.compute, az.network, az.resource, az.storage, and then finally import Excel. So we'll start with az.accounts because that is the basis for importing all other modules. So we'll click on add a module, and once we are there, under upload a module file, we'll choose browse from gallery and then click here to browse from gallery. Once we are on the browse gallery page, I'll click on the search bar and then type in az.accounts. It will take a couple of seconds and az.accounts will appear as the search result. So I'll click on it, and once we have it, we'll click on select. Now from the runtime version, I'll click on the drop down and select 5.1 and then finally click on import. It will take a couple of minutes and then az.accounts will be imported. So we'll wait for this function to get completed and we'll return back after this is done. the importing of the PowerShell module az.accounts is complete. And you can see the new version here, 2.7.5. Now it is time to import the remaining modules. I'll start with az.automations, and for that I'll click on add a module. Once I'm there, I'll click on browse from gallery and then click here to browse from gallery. From the browse gallery page, I'll click on the search bar again and type in az.automation. Now that it appears, I'll click on az.automation and then click on select. Finally, I'll select the runtime version as 5.1 and then click on import. I can add other modules in parallel as well because az.accounts has already been imported. So I'll click on add a module again, click on browse from gallery, click here to browse from gallery and then search for az.compute. After the search results appear, I'll click on az.compute. I'll follow the same process, click on select, then select the runtime version as 5.1 and finally click on the import button as it appears. I'll click on add a module button again, choose browse from gallery and then click here to browse from gallery, and this time I'm going to select az.network. From the search results, I'll select az.network, click on select, and then from the runtime again 5.1 and then click on import. Repeat the process for az.resource. Select it, click on the select button and finally click the runtime version drop down, select 5.1 and click on import. Repeat the process for az.storage. Select it, click on the select button and then from the runtime version click 5.1 and finally click on import. And now is the time to import the final module, which is import Excel. So again, repeat the process, click on browse from gallery, click here to browse from gallery and search for import Excel. Select from the search result, click on the select button. Again, from the runtime drop down, select 5.1 and then click on import. So after all the modules have been imported, we will be good with the configuration of the automation account. So I'll move to the right and scroll down to see if other modules have been imported. So az.resources is still getting imported, so we will wait for the process to get completed. We'll click on the refresh button to see if the import is complete. Search for az.resources and we see that it is still getting imported. So we'll wait for some more time. Similarly, we can search for import Excel as well. And here we can see that the 3 modules are still in progress and finally they have all been imported. So we are good with importing all the PowerShell modules and the configuration of our automation account is now complete and we can get started with configuring the PowerShell runbooks. On to the real meat and potatoes of this cross-service automation process flow. And here in this demonstration, we are going to create PowerShell runbooks. If you remember from our previous demonstration, we had imported PowerShell modules and those modules will be required for creating this runbook. So I'll move to the left and then scroll down, and from under process automation, I'll click on runbooks. Once I'm there, I'll click on the create a runbook button. On the create a runbook page, for the name, I'll provide the name as initiate watcher process. For the runbook type, I'll click on the drop down and choose PowerShell. For the runtime version, I'll choose the more stable one, which is 5.1. If you want, you can give the description, but I will skip that for now and finally click on the create button. It will take a couple of seconds and the PowerShell runbook will be deployed. but there is no code as of now, and for the code we are going to go to GitHub to get that. So I'll click on the other tab, and here is my GitHub page. Now for you can just type in Azure Automation 2898153 on the search bar and you will be redirected to this particular page. From here, you can click on initiate watcher process.ps1 and on that page, click on draw. Once you're there, you have to just copy all the code. Right click, copy, go back to the first tab and just paste the code here. Now, before we move forward, I'll try to explain this code one line at a time. We will start by declaring a few of the variables, and the first one is the tenant ID. For that, we are going to use the command get automation variable and pass the property name as tenant ID. If you remember, we had declared a few of the global variables within the shared resource, and tenant ID was one of them. And this is how you extract the value of tenant ID from the global variable inside this PowerShell runbook. Once that is done, we'll connect to the Azure account by using the command connect AZ account and pass identity property. And this identity is the user defined managed identity. After that, we have two more variables which are static variables by the name of vResource group name having the value of LinkedIn Learning Automation and vAutomation account name having the value of LinkedIn Automation. These variables are hard-coded. Why? Because I wanted to show you the different ways of creating the variables within the PowerShell runbook and PowerShell in general. On line number 12, we have another variable by the name of VS storage account. And again, we are trying to extract the value of the variable storage account from the global variable resource. On line number 15 and 16, we have the start time and the end time. And the bottom line is, using these values, we are going to create the storage context. Reason being, because we want to extract the value of the Excel file which will be uploaded within the container of the storage account. Creating the storage context is a three-step process. In the first step, we are going to get the storage account by using the name of the storage account as well as the resource group name. We will use the command get-az storage account, and in the name we'll pass on the variable VS storage account, and for the resource group name is the vResource group name. After we have the storage account details, we'll create the SAS token for the storage account. For that, we'll be using new-az storage account SAS token. The service is blob type and the resource type is container object, having all the permission of read, write, create, delete and update. The start time is the start time and the end time, which is the expiry time, is the end time that we had declared earlier. The context is the storage count.context. After we have the SAS token, we'll create the storage context. And for creating the storage context, we'll use the command new-az storage context. And we'll pass again the storage account name, which is the stg account.storage account name, and the SAS token that we had created earlier. I will scroll down, and here we have another variable called path. Its value is $env temp/vmdetails.xlsx. $env is the path where the PowerShell runbook will be running. Temp is the folder name and vmdetails.xlsx is the temporary file name. Once we have that, we'll remove that item. So we will remove the vmdetails.xlsx file if that file already exists in that path. After that, on line number 27, we'll get on to the blob container. By using the command get-az storage blob, the container name is create VM. The blob name or the file name is createvm.xlsx, and this is the actual file that will be uploaded to the storage account. And the context is $stg context. It's the context that we had created just some times back. Once we have the blob, we will try to copy the content of createvm.xlsx to this temporary file called vmdetails.xlsx. On line number 31, we'll use the command import Excel. We'll pass on the path with the worksheet name as sheet 1, and we will start at row 1 and column 1. So within vmdetails.xlsx file, we'll start at row 1 and column 1 and try to get the value of each of the rows that are present within the vmdetails.xlsx. So we'll use for each loop, so for each $vmdetails in $excel value, and we will store the value of each of the column for that particular row within the array variable called VM parameter. So we have the name, the computer name, the location, the resource group name, local admin username, its password, the size of the computer that we want to create, the publisher name, the offer name, as well as the SKU. Once we have all the values within the array variable called VM parameter, we'll go on and call another PowerShell runbook, which is create virtual machine action runbook.ps1, and we will pass on the array variable as its parameter. And what's the need of creating another PowerShell runbook? It's because I wanted to make the code more modular and easy to understand. So our next step will be to create this particular PowerShell runbook, which is create virtual machine action runbook.ps1. But before we move on to create another PowerShell runbook, I need to save this one. So I'll go up and click on the save button, and after the runbook has been saved, I'll click on the publish button to publish this PowerShell runbook. It will ask me for the confirmation that if the previous version already exists, it will override. I'll just click on the yes button to confirm, and the PowerShell runbook will be published. After this has been done, I'll click on LinkedIn Automation, and here you see the initiate watcher process runbook already present because it has been published. Once again, I will repeat the process of creation of the runbook. So I'll click on create a runbook. Here I'll give the name as create virtual machine action runbook. For the runbook type, I'll choose PowerShell. For runtime version, again, I'll choose the more stable one, which is 5.1, and I will click on create. So the PowerShell runbook has been deployed, and it is giving me the option to create the code. So I'll go back to my GitHub page, and here you see create virtual machine action runbook.ps1 is already present. So I'll click on it, and then I'll click on draw. Once I'm there, I'll copy the entire code, go back to my Azure page, and here paste the code. Now that this is done, I'll try to explain this code one line at a time again. But this time, before we do that, I'll click on save, and I'll try to explain this code one line at a time, as I already mentioned. It will start with the array parameter variable, and the variable name is vmdetails. This is the variable that was passed as a parameter from the first PowerShell runbook, which was initiate watcher process. Once we have that, we are going to create certain global variables like tenant ID for tenant ID, VNet for the virtual network, and the NSG name for network security group. Now you might ask why we have appended $global here. It is because we are going to use these variables within the function. Otherwise, these variables may not be accessible. There are other two variables by the name of subnet name as well as the subnet ID. These two variables have been left empty as of now. We'll move to the bottom of the code, and the first line that will execute after that is get-subnet followed by load vmdetails. So the first function that is being called here is get-subnet. So let's try to understand this function. So I'll scroll up a little, and here I am on the function get-subnet. The purpose of this function get-subnet is to find out a subnet within the virtual network where we have the availability of the IP addresses. If the IP addresses are available within the subnet, then that subnet will be used for the creation of the new virtual machines. If the IP addresses of the subnet have already been exhausted, then we will create a new subnet, and that subnet will be used for the creation of the virtual machine. The code is pretty straightforward. On line number 73, we are trying to get the virtual network name. Once we have the virtual network, we'll try to find out all the available subnets within that virtual network. We will loop through each of the subnet and we'll try to find out if there are available IP addresses. If the IP addresses are available, then we will populate the subnet name and the subnet ID with the name of the subnet and ID of the subnet. Else, we will be creating a new subnet and the prefix for that subnet will be subnet VM. Once we have the subnet name for that particular new subnet that we have just created, we are going to populate the subnet name and subnet ID with the newly created subnet name and ID. The code is pretty straightforward, isn't it? After the function get-subnet has been executed, it will return back and try to call the function load-VM details. So I will move up to the function load-VM details, and here we are on the function load-VM details, which does nothing more than extracting the value from the array variable parameter that was passed from the initiate watcher runbook, and will try to populate different variables like the VM name, the computer name, the location, resource group, the local admin user and password, the size of the computer, the publisher name, the offer, and the SKU. After all the variables have been filled, a new function createVM will be called and all the parameters will be passed. And this function createVM does the actual heavy lifting of creating the virtual machines within the subnet. So we'll move on to the next function, which is createVM. So here we are on the createVM function. It has all the parameters that was passed from the previous function. So we will use the VM local admin secure password and will convert it to a secure string. Once that has been done, we'll declare the variable for the public IP address, and using that, we'll create the new public IP address. We'll also create the credential object by using the command new-object. After that has been done, we'll use the NSG details, that is the network security group details, to create the NSG ID, declare the variable for network interface card, and then finally create the network interface card. After the network interface card has been created, we'll create a new variable which is virtual machine, and we'll try to configure all the values for the new virtual machines to be created. And after the virtual machine variable has been configured, we'll create the new virtual machine using the command new-azvm. We'll pass in the detail as resource group name and the virtual machine which we just populated, and the location as the location that was passed as a parameter to this function. So finally, we are done with the creation of our second PowerShell runbook, which is create virtual machine action runbook. Since we had already saved this runbook, the save option is disabled for us. But yes, we definitely need to publish this runbook. So I'll click on the publish button and give the confirmation by clicking on the yes button. It will take a couple of seconds, and here we have the create virtual machine action runbook published. Both of our PowerShell runbooks have now been deployed, and it is now time to create the event grid. Why? Because we wish to capture any event that is occurring within the blob container createVM inside the storage account, so that the process of creation of the virtual machine can be initiated. So I'll go to the search bar and search for event grid. And from the search results that appear, I'll click on event grid topic. Once I'm on that page, you will notice that the subscription and the resource group are already pre-filled. We'll just need to fill in the name. So I'll give this the name LinkedIn Event Automation, and for the region, I'll choose from the drop down and select East US 2. There is nothing else to configure, so I'll click on review and create. And after the validation will pass, I'll click on the create button. Now that the validation has passed, I'll click on the create button. It will take a couple of minutes before the event grid will be deployed. So we will wait for this to be completed and will return back after it is completely deployed. Now you see that the LinkedIn Event Automation Event Grid topic has been deployed. I can click on the Go to Resource button. And from here, I can click on Event Subscription to create this subscription for our automation account. But I'll not do it from here. I'll do it from within the automation account. So I'll go back to the automation account, click on the name LinkedIn Automation, and create the event subscription from here. But before we do that, we need to go back to the runbooks and create the webhook for Initiate Watcher Process runbook, because this is the runbook that will be initiated once the event occurs within the storage account. So from the top navigation, I'll click on Add Webhook, and once we are there on Add Webhook page, I'll click on Create New Webhook. Here, I'll give the name as Watcher Webhook. For the date, I'll let it remain as 4/18/23, but remember to copy the URL from here. This is the webhook URL, and once you go out of the page, you will not be able to get back again. So remember to copy this URL, and once you have copied, click on the OK button. And finally, click on Create. Now that the webhook has been created, it is time to configure the event subscription. So from here, we'll go back to LinkedIn Automation page, scroll down to Related Resources, and from here, I'll click on Event Grid. And once we are there, we'll click on Event Subscription. Here, we'll give the name as Storage Account Events under Create Event Subscription page. For the event schema, we'll let it remain as Event Grid Schema. For the topic types, I'll click on the drop down and select Storage Accounts. For the subscription, I'll choose my subscription. The resource group is LinkedIn Learning Automation, and for the resource, I'll choose LinkedIn Automation Storage Account. Once that has been done, for the event types, under Filter to Event Types, I'll click on the drop down and I will uncheck Blob Deleted, because we are just concerned with Blob Created Event when the file will be uploaded. So we are good with this. I'll scroll down, and for endpoint details, for the endpoint type, I'll click on the drop down and choose Webhook. I'll scroll down again, and for endpoint, I'll click on Select an Endpoint. And you remember, we copied the endpoint, so I'll just paste it here. And once that is done, I'll click on Confirm Selection, and then finally click on Create. It will take a couple of minutes and the Event Grid subscription will be deployed. So you see on the right hand side, it says that the deployment is complete. I can click on Refresh, and if it does not appear, I'll change the filter from here. So we deployed in the East US 2 region, so I'll choose that. And our event will be displayed. So we are good with this, and now is the time to test the complete process flow. But before we do that, I'll show you that we do not have any virtual machines yet. So I'll go to the search bar and search for virtual machines. Since I recently visited virtual machines, that is why it appears under recent services. I'll click on virtual machines, and here you will see that there are no virtual machines as of yet. So we are good with this one. Now we are going to go back to the search bar and go to the storage account. Since I already visited storage accounts again, it appears under recent services. So I'll click on storage accounts and then click on LinkedIn Automation. Once we're there within the storage accounts, I'll click on containers under data storage. And then from the right hand side, I'll click on Create VM, which is the container. Once I'm there, I'll click on the upload button, and from the right hand side, I'll click on select a file. I'll choose createvm.xlsx and then finally click on open. Once it has been selected, I'll click on the upload button. The file has been uploaded, and in my opinion, the Initiate Watcher Process runbook must have been initiated. So let's go and check that out. I'll click on the search bar again and then click on automation accounts. Click on the automation account name, and then from under process automation, I'll click on runbooks. Here we have the initiate watcher process runbook. I'll click on it. I'll click on the refresh button and you will see one process running so far. So this is the process that got initiated. I'll click on this, and from within the page we can get further details. So one is that the status shows as running. We can see the input, which is of type webhook data. We also have the output and the errors. As of now, there are no errors. There may be warnings, which does not matter as of now. And we can see all the logs. It shows 0 errors and 2 warnings, and there are no exceptions. So we will wait for this process to get completed and call the second PowerShell runbook, which will initiate the creation of the virtual machine. The status shows as completed and there are no exceptions. So both the virtual machines must have been deployed. To check that, I'll click on the search bar again and then go to the virtual machines. And there you go. I see both the virtual machines deployed. The names are VM1_Windows as well as VM2_Windows. They both have been created under resource group LinkedIn Learning Automation. In the East US2 region, the status shows as running. They both have operating system of Windows with the size of a standard DS1 V2. If we click on any one of the virtual machines, we can see further details, like the private IP address is 10.0.0.5 for the second virtual machines, as well as it has the public IP address. If we click on networking, we get to see the network interface card name, and it shows as NIC_VM2_Windows. If we click on the first virtual machines, which is VM1_Windows, it will show the network interface name of NIC_VM1_Windows. So that completes the process flow for the creation of the virtual machines using the event grid and the PowerShell runbooks. I hope you followed this session and simultaneously performed your lab. If not, then you please complete your demo part so that you have the complete understanding of how the PowerShell runbooks perform and how they are created. Next is the update management using Azure Automation. Update management with Azure Automation helps automate the process of updating and patching the virtual machines. It works along with the log analytics to detect the vulnerabilities and missing important security and other updates, and then mitigating the issues by automatically patching them, keeping the VMs clean, healthy, and up to date. So, in a nutshell, update management with Azure Automation can be used to manage the operating system updates, be it a Linux, Windows operating system, or it is a physical or virtual machines. And these virtual machines can be in on-premises data center or in the cloud. As I already told you, that update management can be used for automatic updating and patching of the workloads. These updates can be run on demand or can be scheduled. It helps you assess and review the status of the onboarded machines quickly for the available updates and manage the patching and updates accordingly in order to remain compliant. A picture is worth 1,000 words, isn't it? So let us try to understand the same with a diagram to have a better understanding. First thing to know is that for update management to work, it integrates with Azure Monitor Logs. This helps in collecting and storing the update assessment data for the workloads that have been onboarded for the update management. For this to work, the Azure Automation account and the Log Analytics workspace are linked together, and the Log Analytics agent are installed on the VMs. These agents are available for both Windows and Linux machines. After the machines are onboarded for the update management, they report their update status based on their operating system. By default, the scan for the Windows machine happens every 12 hours, and for the Linux machines, it is every hour. After the scan on the machines are completed, the log analytics forwards the information to the Azure Monitor logs. These updates can be reviewed and the appropriate action can be taken. For the scheduled deployment, you have to define the target machines that will receive the updates. For this, you can explicitly define the target nodes or select a group that results from the log searches or using an Azure query based on a criteria. When a schedule is defined for the updates, a time is set when the updates will happen. This is called the maintenance window. The updates are installed on the workloads by the hybrid runbook worker. They check for the maintenance and the deployment window, and when the criteria is met, the master runbook is invoked, which in turn initiates the child runbooks on each agent. For any new updates, it takes around 2 to 3 hours for the Linux and 12 to 15 hours for the Windows machines to show up after the respective updates are released. Before the installation of the updates, a scan is run to determine if the updates are still required by the target machines. There are a few more points that must be understood and kept in mind when we are working with update management. The update management also supports the collection of information from these log analytics agents in a system center operations manager management group that is connected to the workspace. This information is about the software updates. Second point is that a particular machine cannot be registered for the update management in more than one log analytics workspace. Update reports from Windows Update Agent to WSys might be different from the updates reported by Microsoft Updates, depending upon when the WSys was last synchronized. For Windows machine, the compliance scan runs every 12 hours. For Linux machine, it is 1 hour by default. After the log analytics agent is restarted, the compliance scan happens within 15 minutes of the restart. Last but not the least, in the scheduled deployment, all the updates marked as optional are not included in the deployment scope for Windows machine. Only required updates are included in the deployment scope. Now that you understand what update management is, it is time for a demonstration on update management, and I hope you are ready with your tenant to perform the lab simultaneously. So there are 3 major objectives that we are going to cover in the upcoming demonstrations. First, we will create the log analytics workspace for defining the scope for update management. This will help with our next demonstration, which will be onboarding the virtual machines based on the log search. We will use KQL for this, which is the Kusto query language. And in the final demonstration, we will be scheduling the update management for our virtual machines. So, what are we waiting for? Let's get cracking. I am back onto my Azure portal, and in this part of the demonstration, I'm going to create a log analytics workspace in order to be able to work with update management within Azure Automation. So I can click on log analytics workspace icon directly from here on my dashboard, or I can click on the menu and then go to all services. Once I'm there, I can search for log analytics workspace. You will see that on the right hand side, log analytics workspace comes up as a search result. So I can click on it. And once I'm there on the log analytics workspaces page, I can click on the create button. Here I am on the create log analytics workspace page. So if I scroll down, I can choose the resource group as LinkedIn Learning Automation. For the name, I'll give it a name of LinkedIn LA Workspace, LA for log analytics. For the region, I'll choose it as East US. Now you may ask me, why East US instead of East US 2? Because all of the resources are in the East US 2 region. The answer is, all regions are not supported. And since the update management is in the East US 2 region, the log analytics workspace has to be in the East US region because that is the only region that is supported. So I have chosen the region as East US and I'll click on Review and Create as there is nothing else to configure. After the validation passes, I'll click on the Create button. Now that the validation has passed, I'll click on the Create button and wait for the deployment to be completed. It will take a couple of minutes, so I'll wait for the deployment and will return back after it is done. As you can see, the Log Analytics workspace has now been provisioned. So I'll click on the Go to Resource button and here I am on the LinkedIn LA workspace page, which is the Log Analytics workspace. From the left-hand navigation, I'll scroll down and from under settings, I'll click on Agents Management. Here we have two tabs, one for Windows Server and the other one for the Linux servers. So I'll talk about the Windows servers first. You will get two downloadable agents, one for the 32-bit machine and the other one for the 64-bit machine. So these agents are needed for the workloads which are not in Azure. So you can install those agents and the log analytics will be passed on to Azure from those workloads. Similarly, for the Linux servers, you can click on the download Linux agent link here, or you can copy the URL from here and download the agent for the Linux servers. For the installation, you need the workspace ID as well as the primary or the secondary key. Similar is the case for the Windows server. When you install the agents on your system, you will need the workspace ID as well as the primary or the secondary key. I'll go to the left and scroll down. And from under settings, again, I'll click on computer groups. These are the groups that we will be creating to work with the update management. I'll scroll down again. And from under workspace data sources, I'll click on virtual machines. Now here you will see two virtual machines, VM1_Windows as well as VM2_Windows. These are the virtual machines that, if you remember, we created in our previous demo when we were working with the runbooks. For the log analytics connection, it shows as not connected. For both of them, the operating system is Windows and they are in the LinkedIn Learning Automation resource group with the same subscription in the East US2 region. So these are the two Windows machines that we will be configuring for the update management. One additional thing that I wanted to show you is the automation account within related resources. I'll click on it. And once we are there, you will notice an error as unknown. Why? Because as of now, this log analytics workspace is not linked to an automation account. That is, it is not integrated with the update management. And that is the objective. In our next demonstration, we will try to configure and integrate log analytics workspace with the update management. We have so far created the log analytics workspace. And now it is time to configure the update management within the automation accounts in order to link the update management with the log analytics workspace. The objective is for automatic updating and patching of the workloads. So for the same, I have this automation accounts link on my dashboard. I'll click on it. I'll click on the name. And once I'm there within my automation accounts page, I'll scroll down and I'll click on update management within update management. So here I want to show you one thing. If you look at the log analytics workspace location, it shows as East US. And if you remember, I told you that since we need to pair up log analytics workspace with the update management, it has to be in a region that is supported. And here it shows East US, and that is what we did. We created the log analytics workspace in the East US region, and the automation account is in the East US 2 region. The subscription is already pre-filled. For the log analytics workspace, I'll click on the drop down and choose LinkedIn LA workspace, the one that we had just created. It will take a couple of seconds for the validation, and after the validation is complete, the button will get enabled. Now that the enable button is there, I'll click on it, and it will take a couple of minutes for linking the update management with the log analytics workspace. So we will wait for the process to be completed and will return back after this is done. Now that the linking between Log Analytics Workspace and Update Management is complete, what we can do is we can click on the refresh button of the browser and then click on reload. What it will do is it will present to you the updated Update Management page, which will have some different information. So here you go. You get the dashboard and then there are different information available for the virtual machines or the workloads. So let me explain it to you. For the non-compliant machines, it shows 0 out of 0. Similar is the case for machines that need attentions. There are 0 values, and for missing updates as well as for failed update deployments, the value is 0. Why? Because as of now, no workloads have been attached with this update management. And in order to do so, we will click on Add Azure VMs. And once we are there within the Enable Update Management page, we can scroll down. And here you see the two different virtual machines that we had previously created using the PowerShell runbooks. The first one is VM1_Windows and the second one is VM2_Windows. We just need to click on the Enable button. Again, it will take a couple of minutes before these virtual machines are linked for update management. So we will wait for the process to be completed and return back after this is done. Now that the VMs have been added for the update management, we can go back to the update management page by clicking on the LinkedIn automation link at the top of the page. And then we can click on the refresh button again. As of now, the machine details do not appear here, but never mind. Let's go to the Log Analytics Workspace. I'll click on the search bar and then click on Log Analytics Workspace icon. I'll click on the name, and once we are there, we'll scroll down and click on Virtual Machines under Workspace Data Sources. Here again, we see those two virtual machines, but this time under Log Analytics Collection, you see that it shows this workspace with a green check mark. Because now these virtual machines have been enabled for Log Analytics and they will send their data to the update management. So we are good with this. Next step is to configure the computer group. So I'll scroll up. And from inside settings, I'll click on computer groups. Here again, I have different options. The first one is to create computer groups within Active Directory. The second one, create the WSUS group, which is the Windows Server Update Service group. The third part is the System Center Configuration Manager group. We can create it from here. But for our purposes, we need to create the saved groups. For the same, I'll click on the Log Analytics icon from here. Once I'm there on the page, you will see something like a query. This is actually very similar to the SQL, and this is known as Custo Query Language, abbreviated as KQL. And this is mostly used by the data engineers. So in order to create the saved groups, let me do certain changes. So I'll remove this second line along with the pipe character. So it now reads as select all from heartbeat, where heartbeat is the table, with the pipe character which represents where distinct computer. I also need the computer IP as well as the operating system type. So OS type. I'll click on run and it shows the details as computer 1 and computer 2 along with their IP addresses and the operating system type. What we can do now is click on save and then save as function. We will give this a name, which is Windows VMs. We can give the same name here under legacy category. And one most important point is we need to check the save as computer group. Once that is done, we'll click on save. It will take a couple of seconds and the group will be saved for us. Now that this is done, we'll click back on LinkedIn LA workspace and click on refresh. And here our new group shows up. So this is a group that we will be using for scheduling the update management for our two virtual machines. So now I'll go back to my automation account. For that, I'll click on the search bar and then click on automation accounts. Once I'm there, I'll click on the name of the automation account, and after I am within the automation accounts page, I'll scroll down and click on update management. Now you will see both the machines that were onboarded, computer 1 as well as computer 2. They both show as compliant, and within the update agent readiness, they show to be ready. So now if I see the non-compliant machines, it says 0 out of 2, means there are no non-compliant machines. So we are good with this. And one more thing, there can be multiple different ways of onboarding the machines for the scheduled update management. But we'll be using the group that we had created earlier in the previous demonstration for the log analytics workspace. So we'll click on schedule update deployment. We'll give it a name of Win Updates. For the operating system, it is of course Windows because we do not have any Linux systems. For the items to update, we have two options. One is groups to update and the other one machines to update. I'll explain each one of them. So let me click on groups to update. Here I can select the subscription. I can select the resource group, which is LinkedIn Learning Automation, and then finally click on add. Under included items, you will see one subscription and one resource group. So you can click on preview, and both the virtual machines will be listed here. For now, we are not going to use this method. So we'll click on cancel. We'll click on cancel again and confirm the selection. We'll do it via the machines to update. So I'll click on machines to update, and here the group will be listed which we had created earlier. So here you have Windows VM. I'll click on that and it appears under selected items. Once that is done, I'll click on OK. Now that the items have been added, we have update classifications. So there are 8 selected items as of now. They are critical updates, security updates, update rollouts, feature packs, service packs, definition updates, tools, updates, and so on and so forth. I'll let remain this selection as is. I will scroll down and let me explain what this include, exclude, update means. So I'll click on it. And here, for the include, you can include all the KB IDs that you want to be the part of the scheduled update deployment. Exactly opposite is the case with exclude. You can list all the KB IDs that you do not want to be the part of the scheduled updates. For now, we do not have anything to be included or excluded, so I'll click on cancel and come out of it. Then we have schedule settings. I'll click on configure. I'll choose the time as 12:11 itself with the date of April 30th, and for the time zone, I'll choose US Pacific. After that is done, I can click on OK. But hold on, let me explain what this recurring means. So if I click on recurring under recurrence, we can have this schedule to run every day or every hour or week or month. If we choose week, we can select the days when the update management schedule will run. And we can set the expiration to never expire. But for now, we can change it to once and then click on OK. Now that this is done, I'll take you to the next step, which is pre-scripts plus post-scripts. So here you will see all the PowerShell runbooks that we had created earlier. And if we create new PowerShell runbooks, those will also be listed. Basically, the reason is because it shows all the PowerShell runbooks that you want to run before the scheduled update management or after the scheduled update management. And how does this happen? Let me show it to you. If I click on one of the runbooks, say initiate watcher process, here you can configure this as a pre-script or the post-script. As of now, we do not want anything from here, so I'll click on cancel and come out of it. Now for the maintenance window, it shows as 120 minutes, which we can change to our own requirements. I'll change this to 30 minutes and we are good. For the reboot options, there are 4 different options. which is reboot if required, never reboot, always reboot, and only reboot, and it will not install any updates. So these options are self-explanatory, and I'll choose reboot if required. That is, if the updates need the systems to be restarted, it will happen. Finally, I'll click on the create button. Again, it will take a couple of minutes and the schedule will be deployed. So we will wait for the process to be completed. The schedule deployment has been completed, and we can verify it by clicking on the schedules under shared resources. It says Win Update, the one that we had just created. I can click on it. And here you can see those options that we had selected during the configuration. What we can do is we can delete it from here, or we can add a new schedule. So for now we are good, but before that, let me change this time to 12:30 noon. So I'll change this to 12:30, and I'll change this from AM to PM. This is okay. I'll click on save, and this is done. So I'll close this, and we are good. I'll go back to update management, and I'll show you something. So if I click on manage machines, here we have three different options. One is enable on all available machines, or we can enable on all available and future machines, and enable on selected machines. These are the options which we have for the existing and upcoming workloads. So if we choose the second option, it means enable on all available and future machines. That means that if there are workloads that are currently there, it will get updated with the update management. And for all future migrations or creation after we have created the workloads, they will get automatically added to the schedule. So I can click on enable, and this will be done successfully. Now let's go back to the log analytics workspace. I'll click on the name, and after I'm there, I'll scroll down and check the virtual machines under workspace data sources. So this is all good. There is nothing to be changed or nothing to be configured. I'll scroll back up, go to the overview page, and here we have configure monitoring solutions. So I can click on view solutions, and it will show me the details of the virtual machines. So it shows me 2 computers assessed, and these are Windows systems. So I can click and drill down further, and it will show me those 2 computers under Windows computers. We do not have any Linux computers, and for Windows computers, the critical security and other updates are 0. That is, that they are not non-compliant machines. If I scroll to the right, we have common update queries as well. So that is not needed for now. I can click back on the LinkedIn LA workspace, scroll down, and from under related resources, I can click on automation account. I can go to account, and here in the overview page for the automation account, you will see 6 completed job under job statistics. Earlier that was 3, and now 3 more jobs have been completed. Now if I go to update management, you will see that the machines computer 1 and computer 2 are compliant, and under update agent readiness it shows as ready, and the job has run a few minutes back itself. If you scroll to the right, it does not show anything missing. So there are no missing critical updates, security updates, or other missing updates. And that is how you utilize update management within Azure Automation for automatic updating and patching of the workloads. Now that we have learned about PowerShell runbooks and update management in Azure Automation, it is time to learn one of the most sought after and widely used feature, and that is desired state configuration. You might be having the responsibility to handle the data center of your organization having thousands of servers, where you wish to quickly and easily enable scalability to your IaaS environment. from a central and secure location, or may want to assign your VMs declarative configuration. Why? So that the VMs are compliant with the desired state as per the organizational policies. And this is where Azure Automation State Configuration comes for the rescue. Azure Automation State Configuration is a configuration management service that allows you to create and manage desired state configuration using PowerShell for workloads. These workloads can be physical or virtual machines, and they can be in any cloud or even in the on-premises data center. Desired state configuration can be used for the management of a variety of machines. These can be Azure virtual machines which are classic, and then physical or virtual Windows as well as Linux machines that are on-premises or in the cloud other than Azure. That includes AWS EC2 instances as well. Now, desired state configuration can be configured using the Azure CLI, PowerShell, as well as in the Azure portal by selecting the state configuration under configuration management. What we will be doing is we will be using the Azure portal for the desired state configuration. In case there are restrictions or any other organizational dependencies or policies where you do not wish to manage state configuration in the cloud, you can still use Azure Automation State Configuration as a report-only endpoint. In this case, you can use Azure Automation State Configuration to check and report the compliance status of the workloads. This feature allows you to set the configurations through desired state configuration and view the reporting details in Azure Automation. One interesting point is that if the desired state configuration extension version on the Azure virtual machine is greater than 2.70, then managing Azure VMs with Azure Automation State Configuration is already included at no extra charge. So for more information on the pricing, below is a link which you can follow and see the detailed pricing information. Let's take our discussions a step further, and I will explain to you about the deployment models for PowerShell Desired State Configuration, the DSC. Azure Automation State Configuration can be done using the capability built into PowerShell starting version 4, where we have the state configuration providers that are baked into PowerShell for the ease of configuration management. There are multiple providers that are around the file systems, registry, roles and features, processes, services, packages, logs, scripts, you name it. And the best part is that these resource providers are being updated frequently. I told you that we only let the configuration know what we want and not how to do it. That means that Azure Automation State Configuration is a declarative technology and not imperative. Therefore, the focus is on the desired state and not on the code on how to do it. So the question is, how is the declarative configuration done? For the DSC to work, we need to create a configuration file in PowerShell, after which the file is compiled in the MOV format, which is the Microsoft Object format, and this compilation in MOV is done for each workload, that is each node. Once the file has been compiled, we need to have these lightweight MOV file staged for these target nodes, where we want the DSC to make the nodes compliant. Now is when the Windows management instrumentation takes care of the implementation of the configuration. Here on the right hand side, you can see an example which shows how the PowerShell DSC files are written. This is a very basic sample just for your understanding. Here we have the configuration with the name of webconfig, under which we have the nodes to be configured. Here we have the sample as webvm1, that's the virtual machine, and under the virtual machines we have declared that we need the Windows feature of IIS. For the Windows feature of IIS to be present, to be installed, we need to make sure that the value of ensure should always be present. The name is web server, as I already told you, and it includes all sub features. And that is where it is set to true. So all the dependencies will also be installed. We were just discussing about the staging of the DSC files for the target nodes on the DSC pull server. There are two ways, or you can say two modes, to accomplish this. One of them is the push mode. In this mode, the configurations are applied to the node via the start DSC configuration command. These configurations are pushed to the local configuration manager, which is the LCM of the target nodes. The second mode is the pull mode, where the configurations are stored centrally, and there is a special service, which is the DSC service that runs on the Windows Server 2012 R2 and above, that has the DSC configuration. The target nodes poll and pull the configuration with the unique IDs, GUID, from the servers running the DSC services so that the correct configuration is passed to the respective node. Time to know how you can onboard workloads for management by Azure Automation State Configuration Service. Best part is that with Azure Automation DSC, you can easily enable VMs for management using Azure Portal, PowerShell, and even with Azure Resource Manager templates. What we are going to be focusing on will be onboarding using the Azure Portal. So what happens under the hood? We have the Azure Automation account and have the state configuration service. When we try to onboard the VMs for the automation state configuration, a PowerShell extension gets installed on this VM, which is the Microsoft.PowerShell.DSC. And this extension runs asynchronously and plays that pivotal role in the state configuration management. This is actually the local configuration manager, as I already said, LCM for the VM. Another important point is that Azure Automation State Configuration supports partial configuration, meaning that although the desired state configuration can manage multiple configurations independently, but if there are two different configurations needed for a particular workload, you will need two different automation accounts. Time to get our hands dirty again. So get ready with your tenants to start implementing simultaneously as you see me perform the demonstration. In this section, we will perform the following steps. First of all, we will be configuring Azure Automation State Configuration. And then we will be onboarding virtual machines for state configuration management. Once that is done, we will be performing the demonstration on the state configuration reporting. And finally, I'll show you how you can perform the integration of Azure Automation Desired State Configuration with Azure Monitor Logs. In order to configure the Azure Automation State Configuration, we need to create the state configuration PowerShell file. So here I am on GitHub, and we will be working with PowerShell DSC.ps1. So I will click on this file name and I'll scroll down, and here is the complete code. It starts with the section configuration, and this is a mandatory section. It has to have a name. Here it is web server. Now notice that this name is very important because when you are configuring the state configuration from within the Azure portal, you need to give the same name. Within the configuration section, we have parameters. So it starts with param, and then within parentheses, we have two string type of variables. The first one is node names. The second one is the account key. For the node names, I've made this a mandatory field. So when passing the parameter, this one needs to have a value. I'm also checking whether this node names is null or empty, which should not be the case. So for that, I've used validate not null or empty. Now, account key is the primary key of the storage account. I know this is not a good way to put the account key here, but this is just for the demo purposes. Otherwise, you can pass it from within the Azure portal as a parameter. On line number 11, we have import DSC resource, name service, module PS desired state configuration. This is not important, but still I'm importing the DSC resource, which is PS desired state configuration, so that if there are any dependencies, that can be taken care. Then we have two more variables. They both are of type string. The first one is the storage account name. Now this is the name of the storage account, LinkedIn Automation. We already know about it. And then we have the storage account username, which is Azure / the storage account name. Why is there a need of creating another variable with the name of storage account username and having Azure /? This is because when you're working with the file share, you need to have the Azure / storage account name. So that is the reason I created this variable. We then have the secure account key, and here we are converting the account key to a secure string. This is needed because until you convert it to a secure string, the PS credential object will not be created. So in order to create the PS credential object, we need to convert the account key to a secure string. And here, my storage credential, we are creating the PS credential object. This will create the credential object for the storage account if we want to access that. Scroll down, and here we have the node names. Remember, node names was the name of the parameter variable which was passed. And then we have the node here. Now, what is this node? Whatever configuration that we are doing for a workload. And node represents the workload here. And the node names will be the name of the computer that we will be passing from within the Azure portal. The first service that we are going to install is the Windows feature of DSC service. So the actual name of the service is the DSC service, and here we are ensuring that it is present. The name that we have given to this Windows feature is DSC service feature. This can be any name, by the way. Scroll down more, and here on line number 27, we have the Windows feature IIS. The actual feature that will be installed is the web server. We are ensuring that this is present, and I'm trying to install all the sub features that is required. So for that, I'm including all sub features and I'm putting the value as true. Post that, I'm ensuring that web management tools are also present, and for that, I'm using Windows feature IS management. That is the name that I've given. And the actual feature is web management tools. On line number 41, we have Windows feature ASP.NET 4.5. So here, the actual feature is the .NET Framework 4.5. And for that, the name is web-asp-.NET 4.5. I'm ensuring that this is present. Lastly, we have the ASP.NET website name for the file. So whenever we are working with a directory or we are working with a file, this is the keyword that we need to use, which is file. So we are ensuring that the file is present or the directory is present. For the credentials, I'm using the same credential that we had created earlier for the storage account because that is what we will be accessing. The source path is the UNC path, and we have LinkedIn automation.file.co.windows.net. Configure VMs is the name of the file share, and index.htm is the file that we need to be copied from the source to the destination. The destination path is C inetpub www.root index.htm. So this index.htm will be copied from the source to the destination. The type, of course, is file. In case you are working with a directory and you want all the files within the directory to be copied, then you need to remove the / file name. So in this case, it will be until configure VMs. And here for the destination path also, it needs to be until www.root. And we need to remove the / index.htm. Instead of file, we need to type in directory. So the type becomes directory, and we need to add one additional parameter of type recurse. So recurse is equal to $true. So this is done now. What I will do is I'll go to the storage account here and I'll show what we have. So I'm within the storage account. The storage account name is LinkedIn Automation. If I click on it, here we have the file shares. Within the file share, we have the file share name as configure VMs. And if I click on it, it has the file name index.htm. So this is the file that we want to be copied from the storage account within the www root of the node that we will be configuring. Next is we are going to configure the desired state configuration from within the portal. In the previous demonstration, we had created the PowerShell DSC file, and now here in this demonstration we are going to upload the same file under the configuration section of the state configuration. This file will later be compiled into the Microsoft object format, which is the MOF format, and will be referred by the local configuration manager LCM within the workloads. So what we are going to do is click on state configuration under configurations management. And once we are there, you will notice three things. The first one is nodes. The second is configurations. And the third one is compiled configurations. Under configuration status, you will see there is a value of 0. Why? Because as of now, there is no configuration and currently there are no nodes attached. And to do so, first we'll be creating the configurations. So I'll click on configurations here and then click on add. Then I'll click on select a file. I'll choose the file that we downloaded from GitHub, which was PowerShell DSC.ps1, and click on the open button. Now for the name, we must give the name that should match with the configuration name that we had provided within the PowerShell DSC. And if you remember, that was web server. So we need to give the name as web server. The description is non-mandatory, so I will leave it as it is. And I'll click on OK. We'll wait for a couple of seconds and then we'll click on refresh. Now here under configuration, it shows as web server, but under compiled configuration count, it shows as 0. To compile this file, now I need to click on the web server, and once I'm there, under compilation jobs, it says no compilation jobs found. So what we are going to do, we'll click on compile. Now here on the right hand side, under start compilation job, it is showing me two fields. One is the node names and the second one is the account key. And if you remember from the PowerShell DSC file, these two were the parameters. So they both have the default value. The node names has a default value of localhost, whereas the account key was the storage account primary key. So I'll not give the storage account key, but for the node names, I'll give the name of the computer where I want to attach the computer to my PowerShell DSC. So here I'll give the name as computer 2. Once that is done, I'll click on OK. It will take a couple of minutes, so I'll pause the video and return back once this process is complete. The compilation is now complete, and under status it shows as completed. What we can do is we can click on view configuration source from here, and once you're there, you will notice the complete PowerShell DSC file that we had created earlier. So this is the complete code and it is exactly the same that we had downloaded earlier. So we are good with this. I'll close this. I'll close it again. And then I'll go back to my automation account and click on the automation account's name. And then finally go to state configuration. Now here I need to attach the nodes. And that is what we are going to do in our next demonstration. Before we continue with the configuration of the nodes for automation state configuration, I wanted to show you something. So here I am on my virtual machines page and it lists both the available virtual machines. I'll click on VM2_Windows, and once I'm within the page for VM2_Windows, I'll scroll down and from under settings, I'll click on extensions. As of now, there are two extensions already available. The first one is BG Info and the second one is Microsoft Monitoring Agent. The third extension, which is the Microsoft PowerShell DSC, will automatically get installed once we attach this node, that is this virtual machine, for the state configuration. So from here, we'll be moving back to our virtual machine to show you that the roles and features that we wanted to get updated via the state configurations are not already present. So I'm here on my virtual machine, and on the right hand side, you will notice the host name as computer 2. So this is for VM2 underscore Windows. I can go down and click on the server manager. And once the server manager opens, you will notice that under roles and server groups, there are three things. The first one is roles, the second one is server groups, and the third one is servers total. That is the files and storage services, the local server, and the all servers. As of now, IIS is not there. In order to further verify, you can click on Add Roles and Features. Click on Next, Next, Next again, and then scroll down. You will notice that the checkbox for Web Server IIS is not checked. That is, this role is not already there. So we are good with this. I'll click on Cancel and come out of it. And now I'll move back to my Azure portal, and from there I'll attach the node with the PowerShell DSC. I'm back again here under the state configurations page, and from under nodes I'll click on Add. Now here again it shows me two available virtual machines. I'll click on VM2 underscore Windows. Once we are inside that page, I'll click on Connect. It will ask me a couple of things. The first one is the registration keys. And I have the option to choose between the primary key and the secondary key. What I'll choose is the primary key. Then we have the node configuration name. I'll click on the drop down and I'll select webserver.computer2. This is the name that got generated once the MOF file was generated, and this was when we compiled the configurations file. That is, the PowerShell DSC file was compiled into the MOF format. For the refresh frequency, if I hover over the information icon, it says it represents the frequency in minutes at which the PowerShell DSC local configuration manager contacts the Azure Automation DSC pull server to download the latest code configuration. So by default, the value is 30. I cannot reduce it below that. So 30 is the minimum time, and this is in minutes. Similarly, we have the configuration mode frequency in minutes. If I hover over the information icon, it says it represents the frequency in minutes at which the background application of DSC attempts to implement the current node configuration on the target node. And this value also cannot go below 15. For the configuration mode, it says apply and monitor. There are other two options, which are apply only and apply and autocorrect. These options are self-explanatory, but I'll choose apply and autocorrect. That is, it will look out for the new configurations, it will apply them, and if there is a deviation, they will be autocorrected. Then we have two checkboxes. One for the allow module override, and the other one is reboot node if needed. So if the module already exists, it will be overridden if we check this box. And for the reboot node if needed is required if there is a need for rebooting the system after the current installation is complete. That is, after the update is done, if there is a need for reboot, the server will be rebooted. So I'll check this. I'll scroll down, and for actions after reboot, I'll click on the drop down. Here again, I have two options. One is continue configuration, and the second one is stop configuration. I'll let remain the selection as continue configuration, and finally click on OK. The attachment of the node with the automation state configuration has already started. It will take a couple of minutes, so we will pause the video and return back after this process is complete. The process is now complete and the status shows as connected. So now VM2 underscore Windows is ready for desired state configuration, and the extension PowerShell.DSC has been installed on this particular node. In order to verify that, we can go to our next tab, and here under extensions, if I click on refresh, it will show the newly added PowerShell extension, which is Microsoft.PowerShell.DSC. So we are good with this one. Now if I go back to my Azure portal where I have the desired state configuration and I click on LinkedIn Automation, I'll go to the main page, and here I'll click on refresh. The configuration status shows as green with one computer. Under node, it shows the computer name, which is computer 2, the status as compliant. And if I click on the report, it will take me to the page where you can see the details of the reports. So the type is initial and the status is compliant. I'll click on it to further drill down. Once the page opens, it will show the report status, the report time, the start time, as well as the resources. As of now, both Windows features and the file are present. So the Windows feature of Web Server IIS has been installed and the file was copied from the storage account index.htm and was copied over to the www root of that particular node vm2_windows. Now, to verify that, what we will do is I'll minimize this and go back to my virtual machine. And here you will see IIS installed on computer 2. Now I'll go to Windows Explorer, click to open it, and then I'll click on Windows C, go to inetpub, and then click on www root. Here it will show the index file. If I click this file to open, it will show hello world. So we are good with this second resource as well. In order to verify whether the state configuration is working correctly or not, what we can do is we can delete this file index.htm from here and then verify whether the state configuration is actually working. So I'll right click on this particular resource and then click on delete. The index file has been deleted and now we need to wait for some time for the index file to reappear, and that is when the state configuration will automatically place the file from the storage account and put it here under www root. So we will have to wait for around 15 minutes because that is the time we had given for the implementation purposes. So let's wait for that amount of time and then we will return back once this is done. Meanwhile, what we can do is we can go back to the Azure portal and look at the report. So again, I'll minimize this. And here on the state configuration dashboard, it shows as not compliant. Under node, it shows computer 2 and the status as not compliant. If I click on this, the status shows as not compliant for the type consistency. I'll click on it to further drill down. And here it shows both Windows feature and file as not compliant. So we will wait for around 15 minutes and return back to see if the file was copied over from the storage account and put back within the www root folder. After a while, if you notice, the current time is 6:22 p.m. and the configuration status shows as green. Under node, it shows computer 2 and the status as compliant. I'll click on it again, and this time under status the consistency shows as compliant, and if I click back on the details page, it shows the Windows feature as compliant as well as the file as compliant. Again, if you go back to my Azure virtual machine, here you will notice the index file back here again, and it was copied over from the storage account to this particular folder within www root. So that is how the state configuration works, and you can use it for your automatic updating and patching and maintain your desired state. Now let us look at how we can do reporting for the desired state configuration. So here we are on the state configurations page where we see the dashboard under the nodes tab, and also we see the computer that is attached to the configuration. Under the Nodes tab, it shows computer 2 and the status as compliant. We can click on it and it will take us to the page where we see the list of reports that gets generated for each run of the state configuration in order to bring the nodes to the compliant state. So the first one that we see is the compliant configuration, and we can click on it to drill down further. Here it shows the report status along with the report time. The start time, the total runtime is 2 seconds. The type is consistency along with the resources that are Windows feature as well as the file. They both show as compliant. If we scroll down further, it will show the node name as computer 2, the IP address, which is the private IP address, along with the configuration mode, apply and autocorrect. So what we can do is we can click on any one of the resource to drill down further, like the file resource, And it will show me further details like ASP.NET website. The runtime was 1 second along with the status as compliant. We can click on it further and we'll get further details. We'll go back here and then click on view raw report. Now here it shows the details in the text format with all the details of the server IP addresses and the time and whatnot. We can export this by clicking on the export button at the top here, and it will get downloaded as a text file. So what we can do is we can click here to open, and here you will see all the similar details like IPv4 address, which is 10.0.0.5, along with the host name computer2. Now, this is the compliant report. In case of the not compliant report, you will also see the error messages here in the same report. As of now, this report is in the text format, but hopefully in the future, Microsoft will be able to provide more options like exporting this report in the CSV format or exporting it to the database. And this is how you can generate the report and use it for further investigations and analytics. This is the last demonstration of this course. And in this demonstration, we are going to configure alert notifications for our Azure Automation account. So here I am on the Automation accounts page, and from here I'll scroll down, and from under monitoring I'll click on alerts. Once we are there, I can create the alert rule by clicking on the create alert rule button from here, or I can click on the create button from the top navigation and then select alert rule. I'm there on the create an alert rule page, and it takes me to the conditions tab. If I click on the scope tab, it shows the proper hierarchy. It shows the resource, which is LinkedIn Automation accounts, under the subscription and the resource group LinkedIn Learning Automation. So we are good with this. I'll go back to condition. On the right hand side, I have to configure it. So I need to select a signal. For the signal type, I have different options. So I'll click on the drop down. I have all metrics, log and activity log. I'll explain about the metrics later, but let us see what log is. So it is all about the logs that is captured by the log analytics workspace. If I go back to the drop down, I can choose activity log, and these are all the logs that are captured by the administrative monitoring service. If I now go back to the drop down and check metrics, these are all the different metrics that are available. So the first one is total jobs, which is the total number of jobs. Then we have the total update deployment machine runs. And the third one is total update deployment runs. What I'll do is I'll choose total jobs. Once I'm there, I need to select the time series. So this is generally the aggregate. There is no other option. So I'll let it remain as aggregate. But instead of the over the last 6 hours for the chart period, if I click on the drop down, I can select over the last 12 hours or 24 hours, 3 days, or over the last week. Let me choose over the last 24 hours, and we see some activity on the chart. I'll go down, and now I need to select the dimension. For the dimension, I have different options. The first one is the runbook name, and the second one is the status. I'll select status. I'll let remain the operator as equal to, but for the dimension value, I'll choose the drop down and I'll select completed. So basically, I'm choosing all the jobs where the status is completed. For the threshold, I have two different options. The first one is static and the second one is dynamic. Static is all about manual configurations, whereas the dynamic is the one where the machine learning system algorithms are used. So I'll let remain as static. For the operator, I'll click on the drop down and choose less than or equal to. For the aggregation type, there are different options. The average, maximum, minimum, total, and count. So I'll choose count from here, and let me give the threshold value of 3. I'll go down, and here for the aggregation granularity period, it is 5 minutes. And for the frequency of evaluation, it is 1 minute. So all the configuration is fine. I'll let remain the aggregation granularity period to 5 minutes and the frequency of evaluation to every 1 minute. So the overall condition is, it will look for all the jobs where the status is completed and the total count is less than or equal to 3 in the past 5 minutes. And this rule is evaluated every 1 minute. Now that this is done, I'll click on Done. So the condition is fine. I'll move on to Actions. So I'll click on Next Actions. Here under the Actions tab, we need to configure the actions that will be taken once the alerts are generated. So we have two options here. The first one is Select Action Groups. The second one is Create Action Groups. The Select Action Groups is all about the existing action groups. Since we do not have any action group existing, we'll close this and we will choose Create Action Group. From here, the subscription and the resource group are pre-populated. We are good with that. For the action group name, I'll give it a name of Alert Actions. The display name will be auto-populated with the name of the action group name. We'll click on Next Notifications. Under the notification type, I'll click on the drop-down and I have two different options. The first one is Email as your Resource Manager role, and the second one is Email or SMS message or push or voice. So I'll choose the second one and I will give this a name which is Alert Notifications. From the right hand side, I'll choose Email and provide my email address. The other options that we have is SMS or the Azure mobile app notifications or voice. We are good with this and I'll click on OK. Now this is all about sending the notifications once the alerts are generated. So I have chosen Email and I've given it a name of Alert Notifications and the selected type is Email. I'll click on Next Actions. For the action type, I'll click on the drop down and we have different options here as well, like Automation Runbook, Azure Function, Event Hub, ITSM, Logic App, Secure Webhook as well as the Webhook. We'll choose Automation Runbook. Once we choose that, we are on the Configure Runbook page. Here, the Run Runbook is enabled. So we'll not disable it by the way, because it has to run. For the Runbook source, I'll keep it at built-in. If we choose User, we'll have to choose the subscription. And then within that subscription, we have the LinkedIn automation accounts. So once that is populated, we'll click on the drop down and choose that automation account's name. Then we have to choose the runbook. And these are all the runbooks that we had created. These are not the pre-built ones. So I'll go back and from the runbook source, I'll choose built-in. Now for the runbook, I'll click on the drop down and choose Stop VM. The subscription is pre-populated. For the automation account, again, I'll choose LinkedIn Automation. I'll scroll down and here I have one option for enable the common alert schema. Now this is enabled only for the built-in runbook types and not for the user runbook types. I'll choose yes and then I'll click on OK. So it is getting validated. After the validation is passed, it will bring me to this particular page. So I'll give it a name of Actions. And then I can review and create. And after the validation has passed, I'll click on the Create button again. So now that everything has passed, I'll click on Create here. It will take a couple of minutes and the actions will be configured. So the actions have been configured. I can click on Next Details. Here on the Details tab, we need to provide the alert rule details. So the subscription as well as the resource group, they are pre-populated. For the severity, I'll click on the drop down. Here we have critical, error, warning, informational as well as verbose. We'll let it remain at informational. For the alert rule name, we'll give it a name of Update Count. The alert rule description is not a mandatory field, so we'll skip that. For enable upon creation as well as automatically resolve alerts, we'll let it remain as checked. So now that this is done, I'll click on Review and Create, and after the validation is passed, I'll click on the Create button. It will take a couple of minutes and the alert rule will be configured. So we'll pause the video and return back after this is done. Finally, the alert has been configured And here you see the total alerts of 1. And meanwhile, I have also received an email notification. Let me show you what that is. So I'll minimize this. And here it says you have been added to an Azure Monitor action group. And if I scroll down, it will show me the action group name as well, which is Alert Actions. I'll go back to the Azure portal, and here under the name it shows update count. So that was the total 1 alerts that it was showing. Here it is. So update count, I'll click on it and it will show me further details. So I can change the user response. If I click on close from here for a minute, the user response as of now shows as new, the severity is informational, and the alert condition is fired. So what we can do is we can click back on update count, and from here I can change the user response. So I can click on this button, and from the select the user response, I'll click on the drop down, and I have 2 options here. One is to change it to acknowledged, the other one to closed. So I'll click on acknowledged and then click on the save button. I'll come out of it. So I'll close this and close this as well. And here the user response after a few minutes will change to acknowledged. Meanwhile, I have also received an email notification for the alert that was generated. So here it is. It says your Azure Monitor alert was triggered. I'll scroll down and under alert activated because it shows the metric name. We had selected total job. For the dimension, it shows as status is equal to completed. If I scroll down further, the time aggregation is count. The period is over the last 5 minutes. The operator shows as less than or equal to and the threshold as 3. So it is exactly the same as we had configured in the Azure portal. And this is how you configure alert and monitoring for your Azure Automation account. I hope it is clear and you have performed your lab simultaneously while I was performing the demonstration. If not, go back and start performing your lab as well so that it is much more clear to you. Wow! We walked a great distance while we were discussing on Azure Automation and its different aspects, and now that you completely understand how Azure Automation works along with its nitty-gritties, it is time for you to explore further on how you can best utilize your knowledge so that your organization could benefit from it. We discussed on how to implement process automation using PowerShell runbooks and integrating it with the ITSM tools like ServiceNow, while it generates events by uploading the data into Azure storage account. We also discussed on how you can also exploit the automated update and patch management for your Azure and non-Azure workloads. And finally, we discussed on the desired state configuration for your workloads using PowerShell, where the Microsoft object format file is compiled or is created and connected to the workloads, and the local configuration manager, that is the LCM, is installed within the workloads as the PowerShell extension, and it checks for any deviation from the desired state, pulls the configuration from the pull server, and corrects the configuration if required. Now I would encourage you for further reading and do a little more digging into Azure Automation. I would suggest that you go through the resources that I believe would be very helpful in expanding your knowledge on this topic. So the first one is the Azure Automation documentation itself. It has a lot of resources like cross-services automation details, the overview on how you can manage updates for the VMs, how you can configure your VMs with the desired state configuration, working with hybrid environments and whatnot. It also has the tutorials on how-tos, getting started, and the videos that would definitely help you out. We then have an introduction to Azure Automation. Here you will learn about the capabilities of Azure Automation and what it can do. The third one is the Azure Updates. Here in this page, you will find all the latest updates on Azure Automation. You can click on the links and then you can follow along on what new has arrived or what has changed for Azure Automation. And it will definitely help you a lot. We then have the pricing calculator. Of course, this is very important because you would definitely want to know how much are you going to spend when you are using the service. So the pricing calculator must be used in order to know your spend. Lastly, we have the Azure Automation Q&A. Now this page contains all the queries and question and answers. Now this page contains all the question and answers that are related to Azure Automation. So these are certain helpful links that you should definitely check out to further enhance your skills on Azure Automation. And now that we are at the end of this course, I hope you enjoyed as much as I did being your instructor. In case you have any queries or concerns or would like to ask something, you can reach out to me to get your queries resolved. I would also encourage you to leave feedbacks and comments that would help me in improvisations going forward.